You can see the questions if they ask.
I think previously needs to.
So, hi, welcome to this live module, and you're free to ask many questions related to this particular subject.
Like that. Very good. Okay.
Hello, Hariharan. Yes. Yeah. I see Hariharan saying hi. I didn't aware of language. I didn't aware of language simulations. I really don't understand what exactly you're asking, but what I feel is you were not knowing the lab-based simulations before, and that's why we will be teaching one particular module on how to use the lab view. I think it will help you during the time. Right now, still we have not finished all the modules, right? So once you are able to see and finish all the modules, you will have more understanding about how to use the lab view, right, for one single applications. And then we will, if you have few more questions, you can definitely ask me the forum. But that is our plan. So the details about lab view will be taught to you. And we will be using this lab view for helping you to understand and design the data acquisition systems. So Sitaram, who is also a teaching assistant in this particular course, I have requested him to show you one particular application of lab view. So if you are able to see and you have taken any course, then these modules, and you will see that at least one session is right now live. So you can just go back and understand how the things are working. And then still you have questions, and you can always ask us in the forum. I'm hoping that our forum, we are trying our best to answer questions if they are relevant. Okay, if they're not relevant, it's very difficult to answer questions. Like, for example, how to join your lab is not really relevant questions related to this particular module or this particular course. That thing you can send me in separate email if you are interested. But the questions related to this particular course, you're free to ask through the forum. I hope, Hariharan, I have answered your question. So just to help you out, these electronic modules that we are learning for industry applications, they are meant for not just industrial applications, but if you see, you can also use it for different applications such as medical applications. Like biomedical applications, for example, if I want to develop a sensor or electronic nose, right? It's a group of sensors, and you have a change in resistance. If it's a resistive sensor, then how to convert that particular value to a readable format. So, because finally, if you are developing a certain sensor and system, the output should be in a readable format for a layman. For example, if I develop a system that can understand whether a person is suffering from diabetes or not, it should just show me diabetes, possible diabetes, or no diabetes. That's it. But how to convert that resistance value to such a format? For that, we need to have a signal conditioning unit in between. That's how and of course, to convert your resistance values to voltage and to drive your controller, we require understanding about op amps and further about data acquisition systems. And that's how we use our lab view, which is from National Instruments. So, any other questions, I'm happy to answer. So I have question from Sai Krishna Siripuram, uh, asking me about future scope of custom layout design. So what I feel is what you're asking is that what are the applications for from the IC design point of view. If there is a question that I currently understood, then the answer would be that the new applications of IC design is in neuromorphic. This is a new area, upcoming area where people want to design ICs which will have the similar functionality like our brain. How our brain works, how it will interact, what kind of neurons will be firing, right? This everything we can replicate in terms of IC design by using the IC design layout software called Cadence. So that is a part of the future scope of IC design, where in terms of nanometer technology, you already know that we are at a very critical point below which right now it's very difficult to squeeze your ICs and the MOSFET. So it's a little bit difficult. But for the application point of view, the integrated specific or ASIC, which is your application specific integrated circuit, is somewhere where a lot of custom design layouts are useful. Also, we have application like neuromorphic computing is another application of the IC design layout. I have all ICs are similar property. This was Sakti was asking. So can you please elaborate your question? It's a little bit difficult for me to answer your question. Because you see, from IC to IC, the properties would be different, right? If it is application specific, then one IC would have a particular application compared to other ICs. But if we take operation amplifiers, then all the operation amplifier would have a similar property. It is meant for similar applications. If there is a question, this is the answer. But if you want to know more, please elaborate your question so that I can answer it more accurately. So, and then Jagdish has asked that how this can be useful for mechanical engineers working in power sector. See, there are something called power op amps. If you have seen power amplifiers, right? So you can design a circuit using the operation amplifiers, signal conditioning circuits to control different application in the power sector. Now, if given an example, I can help you to answer it in a detail. But right now, just quick answer to you is that there are a lot of application in controlling the power modules in the which electrical engineers right now are working on. So I think you being from the mechanical engineering design point of view, first of all, you need to have a clear understanding about how the strain gauges would work. If you know how strain gauges would work, then you will know that how can you connect a strain gauge to a signal conditioning circuit and then further find the applications. However, for the power sector, exactly which area you are focusing on, you need to let me know so that I can help you out. For one example I'll give you is the movement of the solar panel. If you have seen recently, the research is on how the solar panels are moved according to the sun. So it will take the sun, right? So in that way, we are trying to optimize the efficiency of the solar panel. Okay, so that is what the application of you for designing the system such that it can track the sun and you can generate more power or efficient power. Uh, so Sakti has further asked, please classify all ICs. Uh, how you want me to classify? It's still little bit complex, but let me help you. If it is related to op amps or all the ICs, what do you mean by all the ICs? Because there are several ICs. There are microcontrollers is also an IC. MOSFETs are also an IC, right? So we have a lot of MOSFETs in operational amplifier. That is one thing. Then you have a voltage controller ICs, right? So then you have digital logic devices, analog. So which particular ICs you want to classify? This is how it is generally classified. But again, my request to all of you who are asking questions, try to stick with the subject which we are teaching, which is electronic module for industrial applications. And then you can ask me further questions. Classification of ICs are analog ICs and digital ICs, if there is a classification you want to understand. But then within analog, like I said, there are a lot of applications. So which particular application you want to talk, you can be more specific. So, what exactly you will be doing in learning this particular course? What is the application of this course, right? So, what I want you guys to understand is that after learning this course, try to spend some time, design signal conditioning circuits, and then integrate with some sensors or actuators, so you can result in some kind of research articles, right? Whether you want to jump into this particular domain, so you can find a new novel sensors, or if there are some people who are already working on this particular area of fabricating sensors, you can collaborate with those people to design the entire electronic system. That is the idea of this particular course. Along with, of course, where the electronic module can be used for from the industry point of view. So there were two different goals for this particular course that I took in this semester. But that is what I would generally, request you to focus on. Just don't leave this course just to get a certificate. Use this for further application in a research domain. Okay. Okay. Vishnu. Okay. Good. Two-time Vishnu. He or she. I'm sorry. The Vishnu is asking. Tell some real-time applications in speed control of DC motor. Okay. So see the real-time application. I'll give you one example, which is cruise control system in automotive systems or autonomous vehicles. That's one of the example, Vishnu. Hariharan, with similar software suitable circuit simulation for like op amps and other components in offline. Uh, yeah. So you can use multi-sim. You can use Proteus. There are several software. When you Google it, you will find it out. Hariharan. But multi-sim is something that we exclusively use, and so as the Proteus. Shakti asked, lithography and thin film deposition, define briefly. Okay. So thin film deposition is a technique where we grow a thin layer of film. It can be a semiconducting material, it can be a metal, it can be an insulator. When I say thin film, the thin film would be less than a micron, 1 micron or one micron to 1.5 micron. For depositing a thin film, we require several techniques. If you want to classify in two main domain, one is called physical vapor deposition and second is called chemical vapor deposition. Now, in physical vapor deposition, further you want to classify, it will be sputtering, it will be electron beam evaporation, it will be thermal evaporation. While in chemical vapor deposition, there will be thermal oxidation, which is LPCVD. There is something called plasma enhanced chemical vapor deposition, PECVD. And if you want to deposit a film using atom by atom, that is called atomic layer deposition. There is one more CVD called MOCVD, which can deposit multiple metals, multiple combination of semiconductor and metals, combination of insulator metal and semiconductor, and that is called MOCVD. In the research work that we were talking about for fabricating sensors, generally we use PVD techniques, sputtering or EVM or thermal, and CVD techniques like LPCVD, where you are growing a thermal oxidation or oxide using thermal oxidation, as well as oxide using plasma enhanced chemical vapor deposition. All right. And further, you want to understand about the difference or advantage, then PECVD is used at lower temperature compared to thermal oxidation. That is the advantage of PECVD. However, the cons is that thermal oxidation will give you a better oxide film. Quality of the oxide is better compared to PECVD. Again, within thermal oxidation, if you want to further describe, there is a wet oxidation and dry oxidation, where dry oxidation is used for gate oxide. If you guys know what is MOSFET, right? Then there is a gate oxide. Gate oxide is a thin layer of oxide, and it should be free of impurities. That is not be H2 ions creating a holes and impurities in the oxide. That's why you use dry oxidation in case of the thermal oxidation. While in case of the wet oxidation, we use the water vapor. So that is about the oxidation. And then second question is lithography, right? So for the lithography, we use photolithography, we use e-beam lithography, there is a X-ray lithography. For this course, you need to understand what is photolithography. Photolithography is a technique by which you can pattern any kind of metal, semiconductor or insulator. I have described in a course how to pattern, suppose there is a metal, right? And let's say this is a substrate, this is a silicon substrate on which I am depositing a metal. Now, how to pattern this metal? If I want to fabricate a heater, right, then I had to go for a photolithography. Photolithography is where you have to deposit a metal, deposit photoresist, and then there are two types of photoresist, positive and negative. Positive photoresist is a photoresist where the unexposed area would be stronger. That means that if I have a bright field mask, wherever the unexposed area is there, then will be stronger. So if I have a mask which will protect the area of the heater and other area you can expose it, and if I use positive photoresist, again I can transfer the pattern with positive photoresist onto the substrate. That's how the photolithography would be used, and then you have to develop the wafer, and further you have to do the hard bake and etch the metal. That's how you get, and finally you have to strip off the photoresist. For stripping out photoresist, you can go for acetone stripping, which is a stripper for the photoresist. Okay, explain the saturation of op-amp even though the circuit component is working good. How to avoid it? Okay, so if the design of op-amp voltage is higher than the operating region of the op-amp will go to saturation, right? So that is obvious, isn't it? So how to avoid this? That is the question, right? So if I again understand your question correctly, the point is, if the op-amp voltage is higher than the operating voltage of the op-amp, then the op-amp will go into saturation. So you can use one way where either the gain should be, what you can do is, let me just get a hold of the question so I can answer it correctly. So how you can understand this that you should gain of the op-amp you should design in such a way that, or you should tune in such a way that the operating voltage should be higher compared to the designed saturation voltage. So that's how you can avoid the problem of having it. Explain precision diode. How precision we are taken for? Hariharan, I can explain you maybe offline, because I don't think this is a part of this particular course. So I'm really sorry. I am supposed to answer questions which are part of this course, but I'll be very happy to connect with you and answer your questions which are outside the part of this particular syllabus. Okay. Any other questions? Yeah. Yeah. So Revant Kandilkar is asking that I want to know why we used to supply in op-amp. You can use a single supply op-amp as well. There is no point of you using two supply. Depending on what kind of application you are using, you can use either one supply or both supplies of the op-amp. It is just to find the operating region is a bias. It's called a biasing voltage, right? And then within that biasing voltage, if you are within that region, you can use the op-amp for different applications. Generally, the op-amps are used as a switch, and or for the amplification and for the filters. But within the op-amp, if you see MOSFETs, and MOSFETs are generally used as a switch. It's just its function is to on and off, right? How you use the MOSFET, and then how the series of how you are cascading the MOSFET and forming an amplifier is a different ball game. But the point is, these are called bias voltage, so that you understand where will be your operating point, where will be a saturation point, where will be a cutoff point. That's how it is. But you can use a single supplies in op-amp as well. Okay, so I'll answer Subham's question, and then Vishnu is asking some questions. So, Subham is asking how some submarines and ships and aircrafts can't be detected by sensors, which technology they use. Good question. Um you see, if you have seen American Black Hawk, this I think the name of the aircraft, where it will not allow the radar to detect the flight, right? So uh, how to avoid it and what kind of sensors, why it cannot be detected is very tricky questions, because I am not in that particular field. But it has to do with not absorb. It has to do with not reflecting the signal back. For example, how you detect a plane with the help of a radar, right? It is because when you send a signal, it will be reflected back from that object, right? So in this particular case, what they have done is whatever the signal comes, it will be absorbed by the object, absorbed by the material that they use for the flight. So then it will not be sent back. When it doesn't send back, the radar cannot detect. So this is one explanation how the flights are generally not detected in the radar. But as far as submarine is concerned, I have no idea. I'm sorry about that. It is a little bit beyond my research domain, my knowledge as well. Okay, what's the operation of monoceral multivibrator? Why we used in ECG? So in ECG, we need to generate a pulse, right? And the monoceral multivibrator, yeah. But in ECG, generally we measure the pulses, we measure the bits, right? But we have not. If you see the ECG circuits, then you will find that we have not used a monoceral multivibrator in the case of electrocardiogram. All right. So I think this monoceral multivibrator also you can call as a unstable. It's called unstable state. There and that's so the short answer to your question would be that we don't use monoceral multivibrator in the ECG. We have also answered your questions. Please try to go back and see that particular module where we are discussing about the the application of ECG. Right. You can also see the DC motor module for getting more information of how we are using the multi-evaporator system. Yeah, thanks, Ariel, to understand that we need to connect offline, right, to help you out. I'm very happy to help any one of you if it is relevant. If you are stuck in any project, right, I will be very happy to help you out. But this live session is meant for clearing some of the doubts that you may not be able to clear with the help of our NPTEL forum. That is the idea. Yeah, I'm happy, Vishnu, you also agreed and you understood the importance of the monostable and where we can use it. Okay. Uh, yeah, thank you, Subham. Guys, by the way, you can call me Hardik. My name is Hardik. You can call me Hardik. Don't refer sir, professor, right? I'm cool. So you can call me Hardik. Whenever you send an email, say Hardik, how are you doing? Right? Don't send me that email. How are you doing? I'm sorry. When you want to ask any questions, that's what I said. Right? So this is my question. Hardik, this is my question. Yeah, do you have any answer for this question? That is one way of connecting to me. Also understand that if there are 6,000 or 5,000 people who have enrolled in a particular course, to answer all 4,000-5,000 people every day through email will be difficult. So be really specific. Try to send me email only if it's required. Please don't send me email which are not really relevant. But if you're really stuck, you're free to connect me through email. But that is why we have the NPTEL forum, right? If it's related to the subject, you please ask in NPTEL forum. It is outside the subject and you are stuck and there is no one to help you out. You can definitely connect to me via email. Yeah, thanks, Deepak. I'm happy to learn that you guys understand what I teach. See, try to write all the assignments. Try to complete your exams. Okay, so you get the certificate out of this particular course. It is not to judge your understanding or your talent. It has nothing to do with that. But spending some time, you should have some kind of certificate at the end of the course. So let me see another question from Hariharan. Can I just drag that one? Okay, why negative trigger is used in monostable multi-evaporator? Okay, so we will also send you the reply, but the details are that because the stable region is in VCC, right? So because of the diode, the capacitor will charge to a maximum voltage of 0.7 volts, and to restore the state, we require input and non-running which should be lower than 0.7. Hence, a negative voltage will be given and a negative trigger is given. Hariharan, you can find my email ID by writing my name in the Google. Write my name Hardik J Pandya IISc. You will find details. You will find my lab. You will find all the details. Deepak, I want to know what we mean by tolerance and resistance. Yeah, sure. So if you see a resistor, you will see that golden lines and a silver line, right? So that is a tolerance limit. That, for example, if I say 120 ohms, is it 120 ohms? It can be plus minus few ohms, right? That is how the tolerance limit is set. So because if I even fabricate a resistor, if the thickness is not constant, if the length is not constant, if the area is different, the resistivity can be constant, right? Because if I am using the same metal, but if my length is varying, or my width is varying, or my thickness is varying, then I will have a similar resistance with some tolerance limit. So every time if I want 120 ohms, it will be 120 plus minus 2 ohms. The plus minus 2 is a tolerance in a given resistor. For the carbon resistors that you see in a resistor that you generally use, we have a golden lines and a silver line, which will help us to understand uh, what is the tolerance within that resistor. If you Google it out, you will easily find it out. Yeah, Revant, it will be little bit difficult for now to join this course at the NPTEL website, because I think it's already, the registration is over, and this is already, we are finishing the course. So if I rerun the course, then you can join it that time. But however, the videos are available for free, so you can always look at the videos. Somit, I am really sorry, I don't understand cool form MVT. Can you please elaborate what is MVT you mean by that? Yeah, no worries, Deepak. Thank you. So I really don't understand. See, these are very basic questions. Why don't you type monosyl multivibrator and no problems, Swami. Why don't you really write monosyl multivibrator in Google and you'll get all the details? Why don't you ask me a specific question that is difficult? Because it's already given what is quasi-static state in monosyl multivibrator. If you want, I can help you out, but I'm just saying it's very trivial. If you want, then I'll just ask my TA to send an text about the quasi state and see the quasi state. That's fine, Swami. Don't worry about it. Actually, let me just see if I can help. 1 second. I'm sorry. Yeah. Yeah. Thank you for understanding, Swami. Yeah, see, inductors are Hariharan, inductors are very difficult to fabricate. You have seen that uh, uh, if you see a thin film technology, right, or monolithic ICs, you will understand that there is a difficulty of fabricating inductors compared to resistors or capacitors, and that's why it's easier to use inductors as an external component rather to fabricate within the integrated circuit on the same silicon wafer. Same silicon wafer, you have to use a different coil state, fabricate different coils to form the inductors in a particular form, which is difficult in the from the fabricating point of view. While when you talk about the capacitor or resistor, is much more easier. So just to avoid the complexity, we generally don't integrate the inductor in the LICs. We generally use inductor as a external component. Shubham, I really don't understand why you are asking me NAND gate monosyl material. How it is related to this particular course? Guys, I request you to just focus on asking me questions related to this particular course. Okay. Any other questions which are off from this course? Like I said, you're free to send me an email if you are stuck, or ask me through forum. So just to answer Saumit's question, we are replying you through the NPTEL platform. This particular, you can see the review NPTEL login. But recently, Hariharan, people have started fabricating inductors on the silicon wafer, and just to improve the quality factor, the new way of fabricating inductor is to take a silicon wafer, deposit or grow silicon dioxide, etch up it in silicon, then deposit silicon dioxide again, make it flat, and on that you grow the inductor. That way your quality factor of the inductor would be higher compared to the fabricated inductor on a regular oxidized silicon wafer. So that is a recent thing. Yeah. So what we mean is, which we have responded to earlier, is that we are taking care of your question, and we wanted to make sure that we have responded to the questions that you have asked. Just ignore the comment, don't worry about it. So, Deepak, is it a correct thing that we understood? You mean that peak voltage of the signal? That's what you mean? If that is the thing that you want to understand, then we will reply to your answer. We'll reply answer to your question. Supply voltage in your home, the peak voltage is what? How it is related to this course? Is it related? Anyway, 230 volts is what you get, right? So there is a different thing that you have to understand. There's a single phase and there is a three phase, right? Single phase will give you 230 volts. In India, we are using 50 Hz frequency. If you go to some of the countries, they use 110 volts and 60 Hz frequency. Then we have a three phase where 230 plus 230 plus 230 should give you about 690. But actually, it is 440 volts, right? That is because at every time one phase is neutral to respect to another two phase. We have 440 volts. And if the peak voltage that we are talking for a single phase, if 230 volts is what we get, then approximately 325 volts is what you get as a peak voltage. Want to know the root mean square value of that? Then it is 230 volts. So I hope that I have answered to most of you. Okay. So Hariharan has one more question saying that what are the other types of encoders used for measuring rotations per minute? See, magnetostriction type, Hall-based sensors, optical sensors. There are several kind of systems or encoders available for your measuring the RPM. So also this Hariharan, we have asked this question in your assignment also. I'm sure that you guys are extremely smart to get answers and asking me to solve your assignments. But assignment is for you to solve, not for me, right? So, but just to help you out, since it was a question, magnetostriction, Hall effect, Hall sensors, optical sensors. That's it. Don't ask me questions which are asking assignments. Live session is to help you out with the things that you don't get it through the either through the live sessions like a course that we have recorded or through NPTEL forum, and you want to ask something which is different from NPTEL forum, and I can possibly help you to answer your questions. But this live session should not be used uh, for solving your assignments. Okay. See, there is a surge voltage, Deepak. So you need to take care of surge. Now, every device, every system is capable of handling few surges. If you have continuous surge, then your system will burn. So you cannot write down what is the peak voltage when you make a system. The system is meant to handle 230 volts and 50 hertz frequency. That's how it is done. No system will come with that. Okay, what's a maximum limit, what's a minimum limit. That tolerance value already they have taken care of. For example, you have a TV at home, right? So earlier we should have a regulators. Now we don't have that because the things are taken care within the system. So you will not find a system with a peak value, surge values. This much is a lifetime. This is not available. But yeah, just to help you further, there are voltages in some of the countries. They adopt 110 volts, 60 hertz voltage is 110 volts, 60 hertz is a frequency. While in India we are using 230 volts and 50 hertz frequency. So in a way to use 110 volts, 60 hertz, you avoid a possibility of shock compared to the 230 volts, as far as I understand. Okay. I don't know about IISc as some intern program or not. First of all, IISc should be small. As the first correction, it's an Indian Institute of Science, and how we write is I is capital, I is capital, S is capital, and the last one C should be in a small alphabet. Okay. Now, like the one that you see. So IISc as a whole, I don't know about internship program is there or not, but some of the departments and all of the faculty members are free to take interns. For example, in my laboratory, there are few interns, but they are only for 6 months. Any internship less than 6 months is the where, because the research that I focus on requires a person to spend sufficient amount of time to absorb the problem and then to contribute and to learn that particular topic. So my applications, my research in my lab requires a person to spend minimum 6 months if he or she wants to pursue an internship. All right, but depends on professor to professor. Some subjects may not require you to be there for 6 months. If summer internships are available. My lab, it is difficult to have summer internships. So what I would suggest you is you is you can connect to one of the professor uh, uh, in the area of your interest through email and see whether he or she has some internship position available in that particular lab. Okay, so I hope you don't have any other questions to ask me. If that is the case, then we will finish this live session. But if you have any, I can wait for another minute and see. If you don't have any, then great. I am hoping that all of you are learning things from this particular course. You are adding a part of the knowledge that you already have to make your understanding or to improve your understanding about the analog designs a little bit better, and you're learning a little bit new things, in particular how to apply the analog circuits in terms of electronic modules for several applications. All right. So but still, if you have any questions, if you feel that you are stuck, there is no way to help you around, please feel free to ask us through forum. If it is even more pressing situation, then you can send me an email. All right. So I wish you all the best for your career. I hope that you learn a lot of courses similar to what I'm teaching here from a lot of professors. NPTEL is a huge, huge platform where you can learn things for free, right? Where else you will learn things for free, right? Only for getting your certificate, there is a minimum requirement so that we can run this entire program, right? So it's a very small amount of money that is charged for your final exam. Other than that, you see everything is free. So please try to learn as many things as possible to this beautiful NPTEL platform. And I wish you all the best for your career. And I'll see you sometime later. Right? Till then, you take care. I will stop the broadcasting now, since I feel that and I hope that I am able to answer most of your questions, right? So you take care. One more text from us, which is a thank you to all of you for attending and spending time for this particular live session, right? And all the best.